2 plus 7 is less than 10. 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 2 plus 7
now I'm switching it off.
2 plus 7 is less than 10. 2 plus 7 is less than 10. 2 plus
Hey everybody, Dave Lindberg with another episode of THD Podcast. No sacrifice for my vacation. I'm actually in Johannesburg today, but I'm still here to help bring you guys the latest and greatest technologies in audio. Today we have a company out of Israel called Alango Technologies, and they're doing a technology that cleans up vibration signals through barriers. So basically something hits a windscreen or a wall, and then how you can translate that to pick out the audio artifacts that you want on the other side of that barrier. So that's kind of an interesting solution, and it has a lot of applications. So we're going to find out where that fits. But without delay, let's thank the Alti Association. Which side do we want to put them on here? Let's say Alti's over here. We encourage people to go check out Alti. They're a great networking organization for audio manufacturing and components and all kinds of people in the audio industry. And also the Audio Express, we encourage people to subscribe to that publication. And in fact, if you're interested in what we're talking about today, there's been some recent publications, and near the end of our presentation today, we'll actually provide you with a link to find out more about Alango. But without delay, let's say hello to everybody. So we've got Alexander and Robert joining us from Israel. Good late morning, guys. How are you guys doing?
Oh, good.
Very good.
Okay. And staying in for the late shift, Simon in Japan. How are you doing today, Simon?
Yep, very good. I'm still at base, no holidays here.
Okay.
Mhm.
All right. So Alexander, Robert, Alango's been working on all kinds of DSP processing for cleaning up audio for various applications, but you've got an exciting new solution, which is I prefaced, but probably I don't fully explain. So perhaps you guys can go into a more detailed explanation to help people understand what you guys have accomplished here.
Sure. So, first of all, thank you, Dave, and thank you, Simon, for inviting and giving us this opportunity to present our latest developments, latest technologies to your audience.
Mm-hmm.
And it's a pleasure and honor to be here and to talk about that. So I'm Alexander Goldin. I'm the CEO and the founder of Alango Technologies, and Robert Schrager is the director of sales and marketing. Also, it's been with Alango for 10 years or even more. So we will now share the screen. We will give you a short introduction into Alango, because I believe that not all of you are familiar with Alango. So very brief introduction, and then we jump into the technology and its application. So I will share the screen now.
Thanks again for attending. Alango Technologies, we were founded in 2002, so we're not a newcomer. What we do is we make digital sound better. We're headquartered here in Haifa in northern Israel, with additional offices in Armenia, Korea, China, but really handling everything all over the world as far as DSP software technology. And we're in over 75 million products to date. What we specialize in, one of the areas is voice enhancement. And this is so the person on the other end of the call can hear you clearly, whether it's a cell phone or Bluetooth, whether it's some speakerphone that is, or headphone, or various devices, even Bluetooth hands-free in the vehicle, as well as also some voice-controlled device that the device can hear you clearly and go ahead and execute the command. Audio enhancement, so making the music as good as possible with proper stereo effect, raising up spectral components and bass enhancement, sound personalization. What this is about is adjusting the sound, that is the audio, exactly the way that you want to hear it, according to your individual hearing profile. through our unique self-test, and then it's effectuated. Hearing augmentation. This is real-time hearing. We specialize in low latency processing. So for wearing, for instance, a TWS device and having this functionality like conversation boost. So you're in a noisy cafe and you're sitting across from somebody and you can hear them clearly. Now we'll get into the heart of the presentation, the technology we want to talk about today. And it's sound acquisition beyond barriers. So what do you need first? You need a barrier. So you can see a barrier in the center of this page. On the left side is the sound of interest. On the right side is not. So the left side, again, sound of interest, barrier, and the person trying to listen, but the person can't hear because there's no microphone or anything picking up those sounds on the left side. Mm-hmm. It could be some machinery that you're trying to pick up, but there's a barrier, so you can't hear it. It could be a pipe behind a wall, and maybe you'd want to hear or somehow be alerted if there's a leak, but you can't hear because there's a barrier. So you could put your ear to the wall to try to hear the vibrations that are coming through the barrier. Kind of tough. What actually works is a vibration sensor. That signal amplified, and then it will pick up the signal of interest across the barrier. Mm-hmm. But here's where a problem occurs. You can pick up that signal of interest across or on the other side of the barrier. But what if there's some competing noise and interference on your side? Then the barrier is picking up both signals on the side that you're interested in and on your side. So this is the problem. Okay. And here's the solution. Alango's sound acquisition module, ASAM, and what we call Vibrozio DSP technology. So through this sound pickup and adaptive filtering, we're able to discern and pick up only the sound of interest. And this is the heart of the solution that Alexander now is going to talk about.
Okay.
Yeah, so I'll go into more technical details about what we do, and I will start from this from the ASAM acquisition module, which and there may be different types or different variations of this model. Here I showed a picture of two. One is our draft version on the left that we still use for recordings. And it has 3 sensors and a microphone on it. Mm-hmm. And on the right, you see our first generation, which is a more mature version. It also includes 3 sensors. And it includes MEMS microphones. It also includes A to B analog devices, A to B bass. So you can connect several models, you can chain several models simultaneously, put them in different locations. It's also powering the model, so it's with simple twisted pair, you can connect up to 10 or 15 models, chaining them. And then the signal will go to the control unit. So when such module is attached to a wall, to a barrier, the vibration sensor will pick up the vibrations of the wall, and we have 3 sensors here, and the reason is to improve the SNR, because sometimes vibrations are so tiny that the SNR is not good enough to pick it up, and so we use 3 just for that purposes. We have a microphone that is located on the same model, and basically the microphone is supposed to pick up only the sound, or internal sound, the sounds that are on the sensor side.
Right.
And so the sounds outside the barrier and inside the barrier, they are not correlated. And, like patent attorneys say, those skilled in the art will understand that you can just add adaptive filter. An adaptive filter will simulate the transfer function between the microphone and the vibration. You can cancel the interfering signal, and it works. I mean, it works. The problem starts, and when your vibration barrier, when your barrier is not perfect, and there is a leakage of the sound from outside to inside. So there is a leakage of the sound inside, outside to inside, and then and it happens all the time. If we put this in the car, for example, then the car windows they do attenuate the ambient sound between 10 and 20 dB. So it's not a perfect attenuation. If you open the window, then it's becoming much less. What will happen? The adaptive filter will get both signals, inside, internal and external, and basically it will cancel everything, and you will get very attenuated and or distorted signal of interest. So what can you do? And that's where Alango Technology comes. It's basically, we have developed what we call constrained adaptive filter, specifically for this application, that allows to cancel the interferences and still preserve a good quality of the signal of interest. So this is our proprietary technology. We filed a patent application for that. So that's what we introduced as a technology provider, basically. Now, and that's what we call Vibrozio technology, when it's also combined with additional application-dependent processing. It may be noise reduction, it may be silent detection, it may be all kind of application-specific processing that is outside the scope of this presentation, and that's what we called Vibrozio. So this is the end of the first part of the presentation. So we've come to demo time, and let's hear the demos.
So I wonder, can it work in the opposite fashion too? You displayed one where you're picking up the noise from the quiet side of the barrier, let's say. What about if you can't put your device on the quiet side? You have to put it on the noisy side. No, wait a minute. It's the same thing, isn't it? It's the same thing.
No, it's not exactly the same thing. This Vibrozio technology works one way. So from the other side from the outer side to the internal side. What it can do, and we will speak about this application, it can differentiate between sounds inside and outside. And Robert will talk about that, about car application, forgotten pet or forgotten child detection inside the car. But cleaning the outside, cleaning the internal sound using the outside sound, no, it's not possible with this technology.
Right, of course. So the example might be, let's say you're wanting to monitor machinery for a faulty vibration or something, bearings getting old. Then, it makes no sense. The problem to solve is to have the sensor on the outside of the machine casing, not on the inside. That's trivial in a sense, isn't it?
Absolutely. Yeah. And this is a kind of enclosure that you can think that there is some machinery inside.
Yeah.
Specifically, what we have inside, we have a loudspeaker playing a voice signal.
Okay.
That when I put it on, you cannot really hear from this side. Now I will switch off my microphone, and now you will hear actually me through the microphone on the model. Remember, there is a microphone on the model, so you hear myself now through this microphone.
Okay.
And now let me. You will in a moment. You will hear me through the sensor that is attached here. So So this is a roll sensor. Roll sensor
2 plus
signal.
7 is
You
less
hear,
than
right?
10.
You hear the
2
voice
plus
inside.
7 is less than 10. 2 plus 7
But you also
is
hear
less
my
than
voice.
10.
A
2
little
plus
bit,
7
yeah.
is less
Both.
than 10. 2 plus 7
Because
is
this
less
is
than
just the
10.
roll
2 plus
sensor
7 is
signal. There
less
is no
than 10.
process.
2 plus
No,
7
Okay.
is
no
less than
Vibrozio
10.
technology.
2 plus 7
Now I
is
will
less
do
than
even
10.
more.
2
I will
plus
play
7
noise
is less than
from
10.
this
2 plus 7
signal,
is less
and
than
then I will
10.
switch
2
on
plus 7
the
is less
Vibrozio
than 10.
technology. So let
2
me
plus
play.
7 is less than 10. 2 plus 7 is less than 10. 2 plus
Okay.
7 is less than 10. 2 plus 7
Now I'm
is
switching
less
it
than
on.
10. 2 plus 7 is less than 10. 2
Okay,
plus 7 is less than 10.
Okay.
2 plus 7 is less than 10. 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 2 plus
So you heard like as technology works. Actually, we were able to cancel all the noise coming from here and preserve the voice coming from inside. Voices. This voice, it may be machinery, it can be other types of signal, just the voice is easy to demonstrate. So that was one demo.
Okay.
The second demo that we will show is how we can hear through the wall. Basically,
Okay.
you see another module attached to the wall.
Yeah.
Robert, go outside, wait a little bit. So I will also be able to, now I will switch to the
So this is the spy device application where you want to listen into the boss's office.
So now you actually hear me through the microphone here on the wall.
Yeah.
Now, Robert, you can go outside. I will switch to the module, to the output of the algorithm. Can you hear the Robert's voice? Now it's a microphone. So microphone does not hear.
Okay, we hear
Microphone
you.
does not hear his voice. But when I switch to the technology with the vibration sensor, you can hear
Okay, yeah.
Robert talking to
Yeah, we can
outside.
hear him.
So it really works, and
sound processing
you don't hear me.
technology.
So it's a double wall. So it's pretty good isolation. So I can hear nothing on this side, but I can hear through the wall very well. So that's about the demos, the real-time demos that we wanted to show. So
Okay.
we can proceed with the presentation. Robert, you can go in.
The sensitivity is obviously very high. So, is it mostly for industrial applications? Do you think?
No. It is. There are multiple applications, and that's what we are planning to discuss now.
Okay.
I hope you enjoyed the demonstration. Now we're going to go into a few of the Vibrozio applications. So the first one we're going to talk about is pretty prominent. It's actually the first one we identified in automotive. And you can see there's 4 different use cases that are identified here. The first one is acquiring a siren. And this is especially important in today's day and age with new cars that have ADAS or even autonomous driving. We have to identify a siren, even when there's strong music playing inside.
Right.
And 2 is what we call out-of-cabin communication. So picking up somebody's voice or sounds, even when the window is shut, and even if there's loud music. You can see in this picture here, the woman behind the wheel, and there's a menacing-looking person on the other side. Obviously, she doesn't want to roll down the window, but she still would want to hear what's going on.
Right.
3 is a convenience feature. So his hands are filled with groceries, and he wants to open the trunk. And 4 is what you were talking about before, Simon, the case that you had envisioned. Whereas instead of hearing outside, we want to identify inside sounds. In this case, God forbid, an infant or or a pet, something that has been left in the vehicle. We want to be able to pick this up. So here's a very simple block diagram for the first case, siren detection for alerting the driver or the autonomous system. And you could see there's the acquisition module. That's exactly what Alexander spoke about earlier with the vibration sensors and integrated microphone for picking up the cabin sounds. And you can see our Vibrozio DSP technology with the adaptive filtering to discern what's going on outside and inside. And then the interfering sound, which is a car radio playing music or something else. So here we have some recordings. And first, before I play them, I want to just highlight the bottom right recording is what we get to, the Vibrozio output. That's the goal. So what you're going to hear first is just what it sounds like with a microphone outside. Then you'll hear what it sounds like, the siren, that is, with an in-cabin microphone. And third, with just the vibration sensor. And then finally, the Vibrozio output. So we'll go ahead and play the first one, the outside microphone. So first is the outside microphone, just picking up the siren outside.
Okay.
What does that sound like with a microphone that's inside the cabin?
Yeah, I don't hear any silence.
So that's right. You can't hear. You just hear the music inside. So
Yeah.
now let's hear what it sounds like just with the vibration sensor.
Okay.
So you can hear that you're picking up both the siren and the music. And now the last one, Vibrozio output, where we just want to identify the siren.
Okay. Yeah.
So that music has been cleaned out.
Right. Oh, that's good.
Okay, moving on to out-of-car communication. Again, this is so the person inside the vehicle can hear somebody speaking from outside. And for convenience or safety reasons, they do not want to lower or open up the window. It's the same block diagram, the acquisition module. There's some interfering noise inside. In this case, it's a weather forecast we're going to be playing, and our Vibrozio technology.
Now, this is the recording will be a little bit reverberant because it's true recording in a underground parking lot.
Okay.
In a real car. So
we'll go ahead. Again, it's the same setup. So now you're just hearing with an outside microphone, and it's reverberant.
1, 2, 3, 4, 5, 6, 7,
Yeah.
8, 9, 10.
Now with the in-cabin microphone,
Oops.
Area of the quietest conditions probably towards the east of Spain. That's the sunshine.
so you can't hear the person talking.
Right.
All you hear is the weather.
Yeah.
And now with the vibration sensor, what it sounds like.
Area of the quietest conditions probably towards the east of Spain. That's the sunshine here. Cloud average of rain for the north and west.
What you hear is it mixed, the
Yeah.
person speaking outside and the weather. Now the Vibrozio technology, which cleans it so that all you'll hear is the person speaking from outside.
almost.
1, 2, 3, 4, 5, 6,
Okay. Yeah.
10.
So the next application I want to talk about is industrial monitoring and predictive maintenance. This is very important to keeping factories running, identify if there's any problems in any of the equipment, machinery, or pipes, etc. It will reduce downtime, costly failures, And existing solutions are intrusive, maybe not even feasible, and have a tough time discerning what's actually going on inside of the equipment that needs to be monitored from the ambient noise. And in the case of our technology, we overcome all those challenges. So we mount unobtrusively, don't have to get inside of the equipment, motor or anything, and we can discern what's going on inside from the ambient noise. It's a very cost-efficient solution. These modules are scalable. Any updates occur software. They can hear through virtually any type of material that needs to be heard through, like metal or some composite. So that's some of the advantages.
So medical applications, as I said, the first application that we see is this NICU units, neonatal incubator care units, placing ASM sensor outside such unit is not intrusive. It doesn't introduce any problems, and it provides significant, important additional information about the state of the infant, of the baby. You can analyze the crying pattern. You can analyze the breathing pattern, which can identify problems before you can see them on, pulse monitor or oxygen level. So it's an early alert. And unit localization. If you have a crying baby and you have 15 units, how do you know which baby is crying? Because we can identify, our technology, Vibrozio technology, can identify the sounds inside and outside. We can say, wow, this is unit number 7. Please go and take care. So that is one of the potential medical applications. Glass intercom systems. And one classical example of glass intercom system is the communication between patient room and control room in CT scans and nuclear medical scans. So while some of these machines today are equipped with intercom systems, but this can serve first as a backup system. Second, it can serve cases when you don't speak with the patient inside the machine, but with the staff outside the machine that may be really quite far from the machine itself. And finally, we came to the application that comes in mind first when you hear about the technology that allowing hear through the walls. So these are surveillance, security, and tactical applications. And this may be life-saving applications when the soldier need to neutralize terrorists behind the door. It's very important to understand the situation inside. So you can attach the module to the door or to the wall and basically understand the situation inside. Also law enforcement situations where you can monitor people inside some enclosed space, doing it quickly, wirelessly sometimes. So there are a lot of this type of applications as well. So basically we've come to the end of our presentation about sound beyond barriers. And we will be happy to answer any questions. And if there are any questions, please contact us. Or if you want to read more information, there was a white paper published in Audio Express magazine, introduced at the beginning of this presentation, very recent article. So thank you very much again, Dave and Simon, for giving us this opportunity to present Vibrozio and Alango. Thank you.
Yeah. So I've always kind of speculated, but the market for industrial MEMS microphones and industrial vibration sensors is quite large. Is there any kind of perspective on like how many microphones in those, like if we eliminate using microphones for pure voice pickup, but for like alignment issues, or in this instance, it's a combination of vibration sensors and mics. What's the market size for those in terms of MEMS? And then there's, I guess, like a coupling with your algorithm that can be used with that available market.
Well, very good question. The number of microphones. Currently, we use only one microphone on each module.
Right.
So I think I can stop sharing the screen.
Yeah.
So we use one microphone. This is, by the way, the module itself, live. So, and we use three sensors, as I said, three sensors to improve the sound signal to noise ratio when because the vibrations are really tiny and the self noise is noticeable. So for some specific applications where really need even better scenario, you can combine more sensors, or perhaps in 1, 2, 3 years, these sensors will improve, and I believe they will improve because the driving industry for this sensor is through wireless earbuds. When they pick up a voice from skull vibrations caused by user's voice. So this is actually the main. So it's a tens of millions devices or sensors market already. So they were not developed specifically for this application. But I think that for some applications you don't actually need three sensors. Maybe you need one. Now to say what is the total market for that, I think it's quite difficult at this stage. We are in the beginning of this development and also business development. The industrial monitoring is a very big market. We will still need to identify where to start from. We are looking for partners for that. And some of the audience will want to partner with us. We will definitely happy to do some joint development, module customizations, and
I've got a couple of technical ones then. First of all, how critical is the coupling between the vibration sensors or accelerometers, whatever it is, and the surface that you're wanting to detect off? Does it require some special attention?
No. Basically, in this case, it's just with two-sided, tape.
Double-sided tape. Okay.
These are 3M speakers. We tried them for many environments, many cases. You just stick it. That's all. If you want to some more reliable, then you can just use some screw. Like you see, there is a hole here, so you can screw it to attach it with the screw. So, but anyway, two-sided tape works pretty well.
And seems like there's no issue with the vibration coming from the detection surface, the wall, coupling into the microphone signal. Is that already accounted for, or there's just an orders of magnitude difference in signal?
The microphones are designed to be not sensitive to vibrations. So basically, you don't see any vibrations. Not any practically important vibration signal on the microphone.
Okay. And so then your intention is that your customers would implement this into products. You're going to be a technology provider, or you plan to actually build finished goods?
Good question. Depending on the market. For automotive market, of course, we can only be a technology provider. You need to be authorized provider and a lot of, and maybe automotive grade provider. So we are not in this space. For other applications, we are planning to provide both modules and sometimes customized models developed for specific applications. Like today, these are wired models connected through A to B bus, so you can chain them and do the processing in one central unit, which is important, for example, for the location finding. So I can put several models together, combine them in one place, and then understand where the sound is coming from the other side, right? But we are developing now a wireless model that will allow actually to put the model, put the headphones, like Bluetooth headphones, and hear from the other side. So there may be various designs for these models, and we have these capabilities to do the module design and the manufacturing until it reaches very big numbers. But we are also a technology provider.
Okay.
Awesome. Thanks.
All right. So yeah, that sounds good. So we'll put your contact information below in the information. People can reach out to you. We encourage everybody, of course, to like, subscribe, and share. And without anything further, let's say thank you, Alexander and Robert, for joining us today. Very interesting technology, kind of very useful. I think there's a lot of applications for this. So yeah, so thanks everybody for watching. And we'll see you on the next episode. Thanks, guys.